Welcome to our channel AutoDrive. When people hear the name 747, they immediately think of the legendary Queen of the Skies, and any discussion about a 2026 version naturally starts with the legacy of the Boeing 747 program. The 747 has always symbolized long-haul power, global connectivity, and prestige. In this imagined 2026 evolution, the aircraft keeps its iconic double-deck hump but is redesigned from the inside out to meet modern aviation standards. The focus is no longer just on size and range, it is on efficiency, sustainability, digital intelligence, and passenger experience. This aircraft would represent a bridge between classic four-engine grandeur and the ultra-efficient technology expected in the mid-2020s. Structurally, the airframe would rely heavily on advanced composite materials combined with aluminum-lithium alloys. These materials are lighter yet stronger than traditional aluminum, allowing engineers to reduce overall aircraft weight without compromising durability. A lighter aircraft burns less fuel, which directly translates into lower operating costs for airlines and reduced emissions. The fuselage would also be aerodynamically refined, with smoother contouring and reduced drag areas. Even small aerodynamic tweaks, reshaped fairings, smoother panel integration, and optimized airflow over the hump, can significantly improve cruise efficiency over thousands of flight hours. One of the most critical upgrades in a 2026 model would be the wing design. The wings would likely feature advanced raked wingtips and possibly adaptive wing technology. Adaptive wings subtly flex and adjust during different phases of flight to optimize lift and drag. During takeoff, the wings can maximize lift for better runway performance. During cruise, they adjust for minimal drag, improving fuel burn efficiency. This not only enhances performance but also reduces structural stress over time. The wingspan would remain impressive, giving the aircraft a commanding presence while improving aerodynamic performance compared to earlier generations. The engines would represent a major technological leap. As a four-engine aircraft, efficiency is critical to staying competitive in a market dominated by twin-engine jets. A 2026 version would likely use next-generation high-bypass turbofan engines designed for lower fuel consumption, quieter operation, and compatibility with Sustainable Aviation Fuel (SAF). High-bypass engines push a larger volume of air around the core rather than through it, increasing efficiency and reducing noise. For passengers, this means a quieter cabin. For airlines, it means lower fuel bills. For the environment, it means fewer carbon emissions per seat, especially if optimized for SAF blends. Performance-wise, this aircraft would target ultra-long-haul routes, potentially offering a range exceeding 8,000 nautical miles depending on configuration. That capability allows airlines to connect city pairs non-stop across continents, such as North America to Southeast Asia or Europe to Australia, without refueling stops. The aircraft's large fuel capacity and optimized aerodynamics would support sustained cruise speeds near Mach 0.85, balancing speed and fuel efficiency. Takeoff performance would be supported by advanced flight control software that optimizes thrust settings and climb profiles for varying runway lengths and weather conditions. The cockpit would be fully digital and highly automated. Large panoramic displays would replace many traditional instrument clusters, providing pilots with customizable flight data in real time. Enhanced vision systems would integrate infrared and synthetic terrain imaging to improve situational awareness in low visibility conditions. Fly-by-wire controls would translate pilot inputs into electronic signals, allowing smoother and more precise handling compared to mechanical linkages. Advanced autopilot and flight management systems would reduce pilot workload during long-haul operations, improving both safety and efficiency. Predictive maintenance systems would monitor thousands of onboard sensors, alerting ground crews to potential issues before they become serious problems. Inside the cabin, passenger comfort would be a top priority. Improved pressurization systems would simulate a lower cabin altitude, helping reduce fatigue and dehydration during long flights. Humidity control would be better than older models, which often left passengers feeling dry after extended travel. Larger windows would allow more natural light, while dynamic LED lighting systems would adjust color temperature to mimic natural daylight cycles. This helps regulate circadian rhythms, especially on overnight or ultra-long-haul flights. Sound insulation materials would significantly reduce cabin noise, even during takeoff and turbulence. The double-deck configuration remains a unique selling point. Airlines could use the upper deck for premium cabins, lounges, or private suites, creating a boutique-like atmosphere separate from the main cabin. This exclusivity enhances brand identity and passenger appeal. Meanwhile, the main deck could be configured for high-capacity economy seating, making the aircraft economically viable on dense international routes. The flexibility of layout allows airlines to balance luxury and volume depending on their business model. Cargo capability would also be enhanced. Even in passenger configuration, the belly cargo space would accommodate significant freight loads, increasing revenue potential per flight. A dedicated freighter version would appeal to global logistics companies, with reinforced flooring and optimized loading systems. Given the continued growth in e-commerce and international trade, this versatility would be a strong market advantage. Sustainability and operational intelligence would define its modern relevance. The aircraft would integrate real-time performance analytics, allowing airlines to adjust flight paths dynamically for optimal fuel burn. Compatibility with sustainable aviation fuels would help airlines meet environmental regulations and corporate sustainability goals. Improved engine efficiency, lighter materials, and smarter routing together could significantly reduce per-seat emissions compared to earlier four-engine jets. Ultimately, a 2026 Boeing 747 would represent a bold combination of heritage and innovation. It would preserve the grandeur and global recognition of the 747 name while embracing cutting-edge materials, digital systems, and environmental considerations. For airlines, it would offer high-capacity efficiency and premium branding potential. For passengers, it would deliver long-range comfort with quieter cabins and enhanced well-being features. And for aviation enthusiasts, it would stand as a modern revival of one of the most iconic aircraft ever built, updated to meet the demands of a new era in global air travel.